How can just 1% of your data absolutely wreak havoc on your data science model? And this is especially true if you're working with, say, marketing mix models where you have predictors that are highly collinear with each other. So let's look at an example where we are trying to predict revenue from two sources of data, Google Ads and social media ads. And specifically, we're going to generate the data so that we know the exact ground truth relationship between the social media ads, Google Ads, and revenue. So we do the first example where there's no correlation. So the social media ads are just distributed from a random normal distribution. There's no correlation. And then we also get Google ads. And we have revenue where it equals 0.5 times the social media ads plus 0.5 times Google ads plus some random noise. So again, we know what the ground truth coefficients should be in this linear model. It should just be 0.5. And sure enough, when we run just a simple ordinary least squares regression, we get variables that are very close to 0.5. We get it very close to the ground truth in this example. But what happens if we just manipulate 1% of our data where we have this be extreme outliers? So in this 1% of data, which we're going to split into 50 basis points, 50 basis points, so it's 0.5% and 0.5%, we're going to have low Google ads, high social media ads, and high revenue. And then the other half of our outliers, so again, there's just going to be 0.5% of the data, half of 1%. We're going to have high value for Google, low value for social media, and low value for revenue. So you should stop right here and think, what direction, how should this manipulation, even though it's just 1% of the data, how should this manipulation affect the regression results? So in this case, we're going to have high value of social media ads with high revenue. And then when we have high Google ads, we get low revenue. So the model where it's being identified, you should expect that we should get a larger coefficient on the social media ads and a lower coefficient on the Google ads. But how much? Because again, remember, we're keeping 99% of the observations the same, and we're only changing 1% of these observations to be outliers. And you can see this down here. The original data frame had 10,000 observations, and without the outliers, it has 9,900. So it's just 100 out of 10,000 observations. And so when we fit this model with the outliers, you can see social media ads went all the way up to 0.65 and Google ads went all the way down to 0.33. Now remember, the true relationship in 99% of the data other than these outliers is that it should be 0.5 and 0.5, right? So just 1% of our observations distorted these results, and that's with no multicollinearity. That is with zero correlation between the Google ads and the social media ads. And so just to verify that that's all we changed, we're going to take that same data, we remove those just 100 observations. So you can see that N is 9,900. And sure enough, there's the results again on those 9,900 out of 10,000 observations. We're right back to right around a 0.5 and a 0.5. And now let's see what happens when we add correlation between our two social media, our two marketing channels, social media ads and Google ads, which is very common in marketing mix models where there are periods of high seasons where we expect there to be high demand and where marketing teams are pumping a lot of money into all the channels, and there are periods of low demand where we're cutting back on marketing spend across all the channels. So this is a very common occurrence. Now, first of all, if you look at this regression, correlation alone, the multicollinearity alone, doesn't actually affect things too much. We still get a value here of 0.5 and 0.48, which is really close to the ground truth. In this case, all we did was introduce the multicollinearity. We haven't introduced the outliers yet. And so now we're going to introduce the outliers the same way that we did before, but with, again, this time, our data having multicollinearity between the channels. And look what happens to these results. It just gets exacerbated even more. The coefficient on social media ads goes all the way up to 0.91, and the Google ads goes all the way down to 0.07, right? And again, if we confirm, we take out just those 100 observations, just those 100 outliers, and we are right back into 0.51 and 0.48. So, what does all this mean? What is going on here? Okay, so the first thing is we have multicollinearity. So, we have collinearity between these two channels that are highly correlated with each other. But then the bigger thing is that we have this handful of outliers, right? And in these outliers, they are driving the identification of the model. So, what's happening? The model is looking for periods where it can basically attempt to say, okay, when we have like high Google ads, when we have high social media ads, how do we know what's driving the results here, right? And so almost the easiest way of determining how much incremental revenue you're getting is you can imagine if there's only one channel with investments. And I hope you can see why this problem is exacerbated when we have two channels that are generally moving together. Because in this case, we had 10,000 observations, but in most of those cases, these observations are kind of moving along with each other, right? And so the model is looking for differences. It's saying, like, how, if these two marketing channels are constantly moving together, how can we tell which channel is driving more of the bookings? Well, it's going to specifically look for those cases where one channel is high and the other channel is low, right? And so these quirky periods are having an outsized effect on the rest of the model. So now imagine you have this marketing mix model. If there is some period in your time series of marketing campaigns where you have just, let's say, you ran an experiment, right? Or you were running TV ads and something happened where you just ran an absolute flood of ads for one specific campaign, that uniqueness of that period could end up having an outsized effect on your results, on what the model is thinking about that channel, depending on how the outcome was during that period.